So we have our original conditional statement. This is formed by just your regular hypothesis and conclusion. And this is the type of statement that we talked about in the video. You'll see in logic, we don't really use these symbols a whole lot in our course, but you'll see if you ever take another course where you're doing any sort of logic, you'll see some symbols used, P and Q. And what this means, P is your hypothesis, Q is your conclusion. Once we see the next type of statement, it might make a little bit more sense. Like I said, we don't use these symbols a whole lot, but this is saying P implies Q, okay? P implies Q. So an example of a regular old conditional statement, so this is similar to what you did last time. Let's say if the sun is out, then the weather is good. Whether or not that's true is probably debatable, but that is a type of conditional statement because we have the hypothesis and then a conclusion based on that hypothesis. The next type of conditional statement that we need to talk about is what we call the converse. This is formed by switching our hypothesis and conclusion. This is formed by switching the hypothesis and conclusion. So in terms of those symbols, if we're going to switch the hypothesis and conclusion, now we will have that Q implies P. We're literally switching the hypothesis and conclusion. Our statement is still going to begin with if, and we'll still have then in the middle, but what we underlined as our hypothesis and conclusion are the things that will switch places. So what I would like to do is this. In this first statement, what is the hypothesis? What is the hypothesis? Jake?
If the sun is out.
Close. Jordan?
The sun is out.
Remember, we do not include the if and then in our hypothesis and conclusion. So the hypothesis is just the sun is out. And then what is the conclusion? Jordan?
Weather's good.
The weather is good would be our conclusion. So when we go to write our converse, all we're going to do is we are going to literally switch the hypothesis and conclusion. I'm going to, where I have the green, write this part. Where I have the blue, I'm going to write that part. The if and then stay where they are. So the converse would be, if the weather is good, then the sun is out. During our warm-up, but we need to talk about what a counterexample is for just a moment. This is an example that shows a statement is false. an example that shows a statement is false. What we are going to do on this next example says to write the conditional in converse for soccer players can run fast. We are going to determine whether each statement is true or false. If it is false, we are going to provide a counter example. So, we need to rewrite this in our if-then form. Give it a try. Sure, that works. If you play soccer, then you run fast. Your group may not have had this word for word, and that's fine. Make sure it makes sense grammatically. I know we're in math class, but I still expect a complete, grammatically correct sentence, okay? And you'll hear me say over and over and over, it's not grammatically correct, okay? We need to work on that too. If you play soccer, then you run fast. That works perfectly fine. So now what we need is the converse. So this is where we are going to switch the hypothesis and conclusion. And let's base it on this statement that we have here, okay? Brooke, what would be the converse of if you play soccer, then you run fast?
If you run fast, then you play soccer.
Exactly. If you run fast, then you play soccer. Now let's talk about whether each of these statements is true or false. And I'll tell you that they're kind of up for debate whether these are true or false. So let's look at the conditional statement first. If you play soccer, then you run fast. Is that statement true or false? Anybody play soccer?
That is false, because when I play soccer, I do not run fast.
Okay, so there might be a position where you don't necessarily have to run super fast, right? Yeah, if you're a goalie, you might not have to run super fast. So I would be okay saying that's false. I could see where you would think true too, but. And then the converse, if you run fast, then you play soccer, kind of same type of thing. What would be the counter example for that? Misha?
You can play more than just soccer?
Exactly. The converse, or excuse me, not the converse. The counter example for this one we already mentioned. You could be the goalie, okay? The counter example for this one, if you run fast, maybe you run track, okay? Just because you run fast does not necessarily mean you play soccer, okay? So that statement that you could play track, that you could run track, that would be a counter example, okay? Very good, very good. All right. Last thing that we are going to talk about today is what we call a biconditional statement. A biconditional statement. This is a statement that contains a certain phrase. It contains the phrase if and only if. Contains the phrase if and only if. What the biconditional is, this is equivalent to writing two statements. So you know that prefix bi means two. The biconditional statement is equivalent to writing two different statements. It's equivalent to writing the conditional and its converse. Few examples here. It says to write the biconditional if possible. We need to talk about that if possible part for just a second. We can only write we can only write the biconditional if the conditional and the converse are true. We can only write the biconditional if the original conditional statement and its converse are true. So if either one is false, like that soccer example, we could not write the biconditional because we have, actually both of those we considered false. So before we even go to writing a biconditional statement, we have to consider whether our statements are true or false. So with that, if a calculator has batteries, then it will run. Is that true or false? Why is it false? The batteries could be dead. Why else?
May not
Not all
need batteries.
calculators run on batteries.
Okay.
The circuit could be cut off.
You may have run over it with your car.
Yeah.
It might have batteries in it, but if you run over your calculator with your car, it's probably not going to work. So am I going to write a biconditional statement here?
No.
Nope, this is not true, which means there's going to be a no biconditional statement. All right, second statement. If an angle measures 180 degrees, then it is a straight angle. Is that true or false?
True.
True. So our conditional statement is false. We need to still think about the converse. So the converse would be, if an angle is a straight angle, then it measures 180 degrees. Is that true? Yeah. Okay. Our original is true. Our converse is true. So let's look at how we write the biconditional. Remember, it has to include the if and only if. So here's how this is going to look. An angle will have a measure of 180 degrees if and only if it is a straight angle. Last example. If a number is divisible by 9, then it is divisible by 3. Is that true? Yes, it is. Okay. Is the converse true?
No.
If a number is divisible by 3, then it is divisible by 9.
You can do 6, for example.
Perfect. What did he provide for us?
An example.
A counter example. Because we can show that the converse is not true, we are not going to write the biconditional. Very good.